In many of the books, this topic is named as cells in the combination of cell. See what is there in what is there in cells in series and what is there in the cells in combination. See, if the cells are connected one after the another, then it will be termed as cells in series. Like an example, if you take, you have this battery which is connected to resistance, which is then connected to again a new battery, and then it will be connected to a resistance. Okay, so how it is connected? It is connected in the same line. Therefore this will be what? This will be cells in series. How it will work, we will be going to discuss about it. See, what is this? This is your EMF. This is EMF E1. This will be EMF E2. And what is this? This will be your resistance R1. This will be your resistance R2. And here there will be a major resistor, and that will be named as what? That will be named as R. And from this circuit current will flow. From this circuit current will flow. See, if you discuss about this, what about the series combination? In series combination, your current will be equal to same. Just remember, E net over R net. What is E net? E net is E1 plus E2. And what is R net? R net will be R plus R1 plus R2. So this will be equal to what? R plus R1 plus R2. So in series, always remember this will be the formula. The formula will be, yes, see, if I give you the general formula, it will be N E over R plus N small r. Okay, see what we have? We have two EMF, so you can write NE. N will represent the number. If there are two number, there will be E1 plus E2. There will be only one resistance, but there will be many internal resistance. So in place of many internal resistance, what I can write? I can write NR. So this will be the general formula for what? It will be general formula for cells in series. Okay, which I will check it once again. What in the case of series? What will happen in the case of series? What we have? We have a circuit. We have a circuit. Okay, then yes, this will be connected to a battery. This will be connected to a resistance. This will be connected again to a battery. This will be again connected to a resistance, and here we have a big resistor. I will name it as E1, E2, R1, R2, and R. What is the formula for current? If you want to find out the current, so what will be current? Current will be equal to E1 plus E2 over R plus R1 plus R2. From where this formula comes? This formula comes from E net over R net. If you want to check, you can check with Kirchhoff law, but we hadn't discussed about the Kirchhoff law yet. After this topic, we are going to discuss about Kirchhoff law. So here what you can write in place of E1 plus E2, in place of E1 plus E2, you can write NE over R plus NR. So this will be your current. Okay, what is this? This is your cells in series. This is the concept for your cells in series. Now we are going to discuss about the cells in parallel. Yes. Now we are going to discuss about the cells in parallel. But before that, I just want to ask you a question based on the numerical on this. Then we can then we can proceed further. What we have for cells in series? Let's consider we have a circuit. Everyone, look at the circuit. Yes. In this circuit, you have yes. What you have battery, what you have a battery. That battery is connected to a resistor, then again one battery, and again one resistor, and this entire setup is then connected to a major resistor, and that major resistor is nothing but your 10 ohm. So this is, I am naming it as 5 volt, I am naming it as 1 ohm, I am naming it as 6 volt, and I am naming it as 2 ohm. I want to know what is the current flowing in the circuit. Anyone? What is the current flowing in the circuit? 5 volt, 1 ohm, 6 volt, 2 ohm, and the resistor is of 10 ohm. Anyone? Karthik? What will be the answer of current? So what will be a current? What is the formula for current? Current is E net over R net. Okay. Okay. What is E net? 5 plus 6, 11 volt, over what is R net? 10 plus 1 plus 2, that means 13. Okay. You got the answer 11 upon 13? If yes, then you are wrong, because 11 upon 13 is not the right answer. Why 11 upon 13 is not the right answer? See, in this case what happened, we are connecting two batteries, but their opposite poles are connected to each other. So here in this case we will subtract this thing. That was a general equation. So here what we will do, we will write 6 minus 5, and that 6 minus 5 will be what? It will be 1 over what is R net? R plus R plus R, 10 plus 1, 11, 11 plus 2, it will be 12. So your current will be equal to what? Your current will be equal to 1 upon 12 ampere. Sorry, 1 upon 13 ampere. Okay, so your answer is what? Your answer is 1 upon 13 ampere. Okay, chalo. One more question. Sorry. Next topic is our cells in parallel. Cells in parallel. See, in the case of parallel, what we have, I will make a diagram for you. What we have okay. Then yes. So now we will complete this diagram. The diagram, in this diagram you have same battery, resistor, battery, resistor. Okay. Then here you have battery. So what you will do, you will write here, this will be your E1, this will be your E2, this one will be your I1, this one will be your I2. Okay, so now in the case of parallel, what you will do, just same thing. That means you will write E net over R net. This is your capital R, this is your small r1, this is your small r2. So what in the case of E net, what will be E net? E net will be equal to, yes, E net will be equal to, if you will check this thing, you will get E net as E1 plus E2, but as they both are in parallel, you will write E1 upon R1, you will write here E2 upon R2 upon, what is R net? R net will be equal to 1 over 1 plus R 1 upon R1 plus 1 upon R2. This will be the formula. E net upon R net is there, but it is connected parallelly. So in place of E net, you will write E1 over R1 plus E2 over R2. Upon me, you have R net. What is R net? R net is how you will get this R net. You will check the formula for resistance in parallel, and you will get the formula for R net, and you can substitute that formula for R net. We have checked the formula. 1 upon R net is equal to 1 upon R1 plus 1 upon R2 plus dot 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 dot. Okay, from there this formula comes. Okay, then what if there will be a mixed grouping of the cell? And I'll just give you the formula for that. Mixed grouping of the cell. See, if there will be a mixed grouping of the cell, so you will write current is equal to, yes, E. You will write current is equal to Ne upon R plus Nr over M. Ne upon R plus Nr over M. As many EMF you have, you will write E1 plus E2 plus E3 plus E4 and so on. R you will write, then you will write 1 upon R1 plus 1 upon R2. That's why. So here you can write it as MNE over MR plus NR. Okay, this will be the formula for mixed grouping of the cell. So we have discussed about cells in series and parallel in the mixed grouping of the cell. Now let's check some numericals based on this. Okay, so I would like to ask one more question based on the cells in series problem. I will give you the question based on this. Solve it and let me know the answer. After that, we'll go to the numerical section. Let us consider in series you have a resistor, sorry, a circuit like this. Yes. In this you have in this you have 4 ohm. Okay, this is battery. This will be 2 volt. This will be 3 volt. This will be 4 volt. We have to find the current. How you will find the current? Yes. How you will find the current? See, these two are oppositely connected. Once more. See, these two are oppositely connected. That means 3 minus 2, it will be 1. Then that 1 volt, then that 1 volt, and this 4 volt are oppositely connected. That means 4 minus 1 will be how much? It will be 3. So the same formula we'll use. We'll use the formula that I is equal to E net over R net. What is E net? Yes, 4 minus 1, that will be what? That will be 3 over, what is R net? R net is 4. So your current will be equal to what? Your current will be equal to 3 over 4 ampere. Okay, how we got this? See, these two are connected in parallel. That means 3 minus 2 will be 1. These are connected in parallel. So that means 4 minus 1 will be equal to what? It will be equal to 3. So this is how we got the formula for I. Okay, so the next one is, yes, next one is your Kirchhoff's law, your Kirchhoff's rule. Sorry, we have some questions in cells in series and parallel. Let's check some questions. Yes. So the questions are, yes, the questions are, a 10-volt cell of negligible internal resistance. Let me highlight the point. Yes. A 10-volt cell of negligible internal resistance are connected in parallel to EMF 200 volt and internal resistance 38 ohm. Find the value of current in the circuit. We have to find the current in the circuit. The question is, we have 10-volt cell of negligible internal resistance parallel across the battery of 200 volt and internal resistance 30 ohm. Find the value of current. We are supposed to find the value of current. How you will find the value of current? Anyone? See what is given in this case. We have we have two batteries for 210 volt, 200 volt and 10 volt. So it will be 190. We have net resistance of only 38. That means you can easily find the value of current. I'll make you solve this thing. You have two batteries. You are supposed to find what? You are supposed to find current. We know the formula for current. What is current? E net over R net. What is E net? Yes, net EMF. What is net EMF? This is 200 and this is 200 and this is 10. It is connected oppositely, so that's why what we will do, we will write 200 minus 10. It will be what? It will be 190 over. What is R net? R net will be 38. What is 190 upon 38? It will be 5 ampere. So your value of current will be what? Your value of current will be 5 ampere. Okay, then we have, what will be the grouping of cell when current in the circuit is Ne over R plus Nr? It will be parallel grouping, it will be series grouping, it will be mixed grouping, or it will be no grouping. I repeat the question. Question is, what will be the grouping of cell when the current in the circuit is Ne over R plus Nr, parallel, series, mixed, or no grouping? Mixed grouping. Akhil? Check the formula for parallel one. In mixed grouping, we have used the term M. It is not the mixed grouping. It is not the mixed grouping. Even option of no grouping will be eliminated. The options can be from parallel or series one. See, I told you in series what will happen. In series, you will write E1 plus E2 upon R plus R1 plus R2. That means E1 plus E2, you can write it as NE over R plus NR. So what will be your right answer? Right answer will be series grouping. This answer is from series grouping. Okay, Akhil? Yes. Now the question is two identical cell, each of EMF E having negligible internal resistance, are connected in parallel with each other across external resistance R. What is the current through resistance? Parallel. In the parallel case, what will happen? Yes, in parallel case, your E will be same. E will be equal to E1, that will be equal to E2. And what is the formula for I? I is nothing but your E net over R. So what is E net? E net is your E. What is R? R will be your R. So your current will be how much? Your current will be equal to E over R. Okay, so these were the things in our topic cells in series and